All right. Yeah. All right. Here we go. So it's 2 hours UTC, and it's once again time for Astronomy Daily Live. So welcome everybody. Come on in. Come on in. I like to spend 3 or 4 or 5 minutes or so just sort of babbling here, not saying much, just letting everybody come on in. Hopefully everybody's getting their notifications. If they haven't hit that bell, you probably won't. I don't know how well that actually works. I hope it works pretty well. And let's see. So yesterday's live stream got another thumbs down, which I greatly appreciate this special attention. Yeah, I think that's pretty neat. So that's like four live streams in a row now. I've gotten at least one thumbs down. So, and this is just a reminder to you all that, if you like this kind of, I guess you call it content, then give it a thumbs up, because that will, I guess, tell the YouTube algorithm to make this more visible. And I've noticed that, right? There have been a couple occasions in the past couple of months where somebody completely new has come into the chat, and it's like, where did you hear this? And it was a suggested video. So yeah, these things are getting around, and that's pretty cool. Like I keep saying, though, I'm not really trying to cast any kind of net, throw this big wide thing out there and pull it in and see what I get. Now I'm more into the harpooning thing, where it's like, there it is, bam, right, and then reel you in. So yeah, but yeah, it's kind of interesting that somebody, right? I assume that it has to be an actual human person is doing a thumbs down. So it's like, I think that's kind of interesting. So anyway, but this live stream is all about the science of astronomy, and we forget about pretty much everything else, right? Now, consider this like a virtual porch, right? Where it's evening, and we're all out there, and we have the lounge chairs, and maybe it's dark, a little dark. You can hear all the crickets and everything, right? And we're there with our most favored consumable, cheers, and just sort of having a conversation about a topic that we all really, really, really like. And I try to limit it to about an hour or so, just because I do respect everyone's time, and I think it's very, very cool that anyone is willing to give up their really important time. I mean, time is like the most precious thing that we have, right? I mean, it's that and like health, those are pretty high up there, right? So precious things. But here we are, right? Spending a little bit of that time talking astronomy, and talking science, and yeah, some tangents, but try to do not too many of those. So, well, welcome everybody. I see that Tom is on the panel again. Hey there, Tom.
Hi, Cosmic. Hi, everybody. Hope everybody's doing well tonight.
And I see Bobby's there also. Hey, Bobby.
Hey, I wasn't thinking about joining if it wasn't for the TV and stuff, but I think if I keep it down to about 5 notches instead of 10, 15, or 20. I usually keep it up to 20. But at 5 notches, I think that'll be pretty darn good. You won't be able to hear about it. Because right now my TV it's got that 7.1 without the 7.1.
Huh. Okay. All right. Well,
And I'm watching, for those of you that does not know Jill's for official SWL channel or any of his tech channels, he's actually at that karaoke party tonight.
Yeah. So Bobby is doing a dual thing. He's trying to be like somebody else I know.
Uncle Bill, where is he at?
Where is he? Yeah. Actually, I'm gonna check the chat here too. Well, Andy, hey there, Andy. Nice to see you in the chat.
Yeah, what's up, Andy? Good, great to join us at that radio show today.
Oh, cool.
And just want to let you know that is tomorrow. It will not be at the shortwave channel. It will be something called the BHF UHF channel, and it's going to be doing anything that's in the BHF UHF range, like satellites and repeaters, maybe some police or something like that.
Yeah, very, very cool. Yeah, check out Jill's YouTube channels. It's official SWL channel. Is that it?
Yes, that's correct. And his BHF is UHF channel. His channel name is official BHF UHF channel.
Okay, cool. Yeah. Jill's a great guy, and his live stream definitely inspired me to start this live stream, because he just sits there and he talks about things that he really likes. And
I think there was something about YouTube oriented about it. But last week's live show that Jill's did, he had to take about maybe 13 seconds out of it because of a copyright claim.
Oh, really? Yeah. They got him, huh?
Yeah.
Pretty good.
And it's kind of a bit messed up. Just one freaking second of that content and you just get a strike. That's it.
Yeah. It might be a little draconian now, but I mean, I can only assume, right? I can only assume that everybody's trying to do as good as they can. So
Jill's about to sing again.
What's that?
Jill's about to sing again.
Oh, that's cool. So you got to assume that they're trying to do as good as they can, and even if it isn't good enough now, they're probably working on it. They're probably worrying about it. They're probably, I mean, I can only assume that they somebody's on this, and sort of the draconian things now, where I mean, it's very obvious, right, that it's automated. I mean, that would be the only rational way to do it anyway, right? Is to have, some piece of software listening to, the audio, and determining what it is and what it means and all of that. So that's probably going to have to change, but I think it will, right? I mean, especially if those of us who are doing this put up a fuss when there's a problem, because that's our way of trying to correct the problem, right? Is expressing what the problem is, and then it's up to them, to listen and understand, and then do something about it, to make a fix. and that might break something else. Don't know. Don't know. Hey, Eureka, nice to see you in the chat. Cheers.
And,
So,
and
so I
there
think,
is Uncle Bill and Iruko, if you didn't mention.
yeah, I just said howdy to
Yeah,
Eureka.
okay.
Oh,
So, welcome those that join.
yeah. There you go, Tom.
Oops, had the mic muted. I'm just a fan of astronomy and other things having to do with space and exploration, planets, stars, galaxies, all that. I saw Cosmic used to be a participant in some of the Astronomy Cast and Weekly Space Hangout chat. See him there, and then somewhere along the lines, I saw his announcement for he's going to start his own stream, and I checked it out. I've been trying to catch him when I can since then.
Yeah, and very much a regular, very much a regular, which is
I
greatly
think
appreciated. I think it's cool.
when I first heard about you be doing those astronomy streams, I think it's in one of those Jules' channels and stuff. I think mostly around the radio side. And you were saying that you was going to do an astronomy stream. And I was like, why not subscribe to? And I got this feeling that I should subscribe to you and stuff. But the first time it was supposed to be my first show that day, you was under the weather, so I had to wait till the next day and watch the live stream and stuff.
Gotcha. Interesting. Yeah. I think it's great. And like I said, I mean, my main thing is just to share a passion. Not necessarily here, to try to teach you anything, or to tell you how things are, or answer any kinds of questions or anything. I mean, I'm happy to do that, but yeah, I like it more casual, and just a little bit more fun, following our noses, right? So, all right, well, cool. Speaking of following our noses, I'm sort of getting back into this art thing a little bit. I continue to want to do things with all kinds of astronomical data, and so yeah, I've sort of jumped back on that a little bit, and maybe I definitely want to start talking about Barnard Star. But I thought
you were saying that you can do that yesterday, so yeah.
Yeah, and I definitely do, but I think I'm just going to walk through some freestyle art here that I've been playing with a little bit the past couple of days. It's all that I'm doing in terms of the raw data is I've been taking data from Gaia. So I've been getting position in the sky, parallax, proper motion, magnitude, that kind of information.
And before you are able to continue, Iroko Roboto wants to introduce to our panelists. Yes, my name is Bobby, and I am more of a stay at home and stuff, because once you're on like disability and Social Security, you're always on it. And if I was off to go back to work, I mean, I've been there since I was a kid, and so unless somebody needs any help, I'll be there and stuff. And so I love like radio. I like radio stuff. Um, and I'm like a bit there when it comes to astronomy and stuff. I love the shuttle launches when it was around and stuff. And I'm just like having a good time and stuff. And I think Iruka wants to introduce yourself too, Tom.
Oh, he just did.
Okay.
Did it.
Okay, I wasn't.
Done deal. Yeah. I think I've got a great crowd here. The neat thing is that I can sort of keep track of the number of live viewers here, and it's an absolute fact that a number of people watch this later, right? Not live, because I'll have. I mean, sometimes I'll get up to 9 or 10 live viewers at one time, and I'll look at the number of views the next day, and it's in the 20s. So so there are a few people that watch this live, but there's probably about an equal number of people who watch this later. So hi to all of you out there. So yeah, very, very cool. Anyway, let's. So what I did is I've been looking at Gaia Data, and so here, let me share my screen, and I'll just sort of walk you through a little bit of this. Hide that. I'm going to get rid of that for now. That. Whoop. Okay, that's gone. GIMP is that. Okay, so let's start at the beginning, which is this it? Come on.
And this is like that binary star that we was talking about yesterday, right?
Yeah. Barnard Star. Turns out that it does have a planet apparently. So yeah, we're going to cover that pretty pronto here. Let's see. So this is a patch of the sky. It's about 1 degree square. So let's plot all these stars here first. So this is a great program called GNU Plot. It's an amazing plotting program. You can do. It's pretty amazing what it can do. And I've always found that figuring out what it can do is best by just thinking about what you have to do and trying to figure out if it can do it or not. So just not necessarily trial and error, but you got to look up a lot of things. Let's see, set data file separator, comma. So now we're going to plot. And let's take a look. I don't remember what the columns are. Stars. 2. Okay, so we'll just do a 3D plot. Yeah, S-plot. 3 dimensions. We're going to call it stars 2. So we're going to use column 2 for the right ascension. Right? Here's column 2. Here's column 4 for the declination. And this one way out here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Column 10 is the magnitude. Oh, and I think column 1, 2, 3, 4. Is it 5? Let's go look. I'm not going to remember it that way. I can remember it this way. So 1, 2, 3, 4, 5, 6. Column 6 is the parallax, which is effectively the distance. All right, so column 6. 1, 2, 3, 4, 5, 6. Right. Using 1, 2, 4, and 6. And then we're going to set a point size.
Now, on the Gaia data, are we able to get like fits or any type of imaging, or no?
On the what?
On the Gaia, can we get any imaging or any fits, or all you get is just data?
This particular archive is just querying a database. Yeah, so this is sort of the processed data, right? They came out with a data product that they call a data release, and I believe that all that data actually does also contain the images and all that, but I haven't really taken the time to look for that yet. I probably should. It's there. Points. Point type 7 is a little circle. And make them black, and point size is going to be variable. I think that'll work. Yeah, there we go. So let's see here.
And you're using dots or points or something, right?
Yeah, so these are the positions of the stars in the sky. This is how they would look like to us. It's just like that. And the size of the dot represents how bright it is. So I'm going to make those a little smaller. That. And then the x-axis here is the right ascension, right? And I think, I'm not quite sure if this is right ascension in hours or if it's right ascension in degrees. Not quite sure. It doesn't matter. It doesn't matter what it is. And then, actually, I've got this the wrong way around. So here, let me. So that's what it looks like in the sky. That. Because the declination.
Okay, welcome Space TV. Are these stars that has those exoplanets or no?
No. This is just a random piece of the sky. Basically, like half a degree on each side. All right, so this is about as large as the full moon, right? It's about that size, and these are all the stars down to, I think, 19th magnitude in that very, very small field of view that I just randomly chose, just random, right?
Now I have a question for Space TV. Do you have any kind of content about astronomy or something? If so, I might try to subscribe to you and probably may watch about a few videos.
I think I'm pretty sure Space TV does. Pretty sure pretty sure, but Space TV can answer for sure. But so what I've done in this case is I've added a third dimension, which is the parallax value, and parallax is directly related to distance. So the larger the parallax, the closer the object is. And so I can just rotate this a little bit, and we can actually go into the third dimension like that. And I can actually go all the way. So this is now flat, right? So now we're looking at right ascension along the x-axis. Declination is sort of, in and out of the screen. And parallax is now here. And yeah, funny enough, there are some stars that have negative parallax, which actually can't exist. And my understanding is that these are just errors in the measurements. So yeah, it just when you run this through an automated system, some things are going to get out. So what I can do is I can actually tell it to start at 0. Back.
Okay, so Uncle Bill Durham, random means some may very well have exoplanets candidates, but he says correlation is very coincidental. Or coincidental.
Oh, yeah, of course, right. All right, cool. So yeah, so here is the parallax of these stars, and as you can see, the larger the number, like I said, the larger the number, the closer the object is to us. So here's a really, really faint little guy that is sort of the closest one, right? The brightest ones aren't really the closest ones. The brighter ones tend to be, but not really. Not really. So then, this tool allows me, to sort of rotate things, and that's where it sort of gets a little bit fun. You can really see spatially, right, in 3 dimensions, where these objects are relative to us. So it's kind of a neat view, but that really isn't the artsy thing that I wanted to show you. Because yeah, I think you've seen all of this before. But what I thought that I would do is, I'm going to get it back to this, is simply take this pattern of stars and take each star and just sort of rotate it around the center of this star field. And so I did that, wrote a little program in Perl again. Here, let me, I need to make this a little bit bigger. Oh, wrong way. Zoom in. Like that, let's maximize this. So yeah, this is just a little Perl program. Oh, I guess I can't. I'm going to work on my screen a little bit here. Anyway, so just a really short little Perl program that takes this file as an input, right? Which is just the Gaia data, right? It's exactly the same thing that I plotted. And it records ascension, the declination, the magnitude, and the parallax, right? So that's what these arrays are filled with, is all of those. And there's, how many stars are in here? So there's 262 stars in this list. So
yeah, it's kind of like a bit crazy when you're doing some astronomical things. You gotta like at least try to write the decent program and stuff.
yeah, you know, most astronomers are at least amateur programmers, because yeah, you just uh, um, out of necessity, the the work that one astronomer is sort of specifically doing is pretty specialized. It's pretty custom. So yeah, most astronomers have some programming experience, almost always. Okay, so then what I also do is I give it a right ascension and declination of the center, right? So then these three lines here actually compute the distance between a given star, star M in this case, and the center. And then just using a little bit of trigonometry, I can actually, take that point, and actually this is commented out, so you can ignore that. I go between two different angles, and I just rotate that that star like around the center of the image. And then I can also colorize it, which I've done here. I've done it in a couple of different ways. I'm going to go back to doing it like this now, and then I'll show you what else I did. So yeah, let's just run this, and I'll show you what it produces. That's a Perl script. Let's see. Just do this one. Yeah, that'll do. Okay, that didn't take too long, and this output can be very, very large, very large. I think let's see, how many points are there here? There's 120,000 points in this plot. Now I've created a GNU plot script sorts that creates the actual plot, and these are pretty close to being exactly the same commands that I just used. I'm just adding some colorization, and I'm writing it to an output file instead of onto the screen. So we can run that. And that takes a little bit of time, not too long. And let's see, let's go ahead and open it with GIMP.
Okay, on computer during while we wait, very obvious to imagine 2 data points in 6 months apart confusing certain proper motions for negative parallax, but seems like additional data points would eliminate such confusion.
Yeah, and that's exactly what it is. I sort of investigated that a little bit, because I saw that right away, and it's like, I had to think about it for a couple of seconds, but it's like, no, there's no way to have negative parallax. So yeah, I think that's actually one of those impossible things. So so yeah, I mean, right away, it's like, well, it's got to be a measurement error of some sort. So yeah, and that's exactly what it is. Anyway, so this is what this thing produces. So that's the same star pattern that you saw before, except now it's each star has rotated around the center by some angle, right? It starts at some angle and then goes a certain number of degrees, and that's it. And each star is different, and then each star has a different color. And then the size of these depends on the brightness of the star. So here I can add a layer here to just sort of see what that looks like. So I think that's kind of interesting. It's very colorful. So then what I was doing was I was actually making these lines much fatter. So here, let's see if we can do this here. Okay, all right. Well, that's that, and I guess I should have mentioned that. Let me pull this up again. So this is looking like straight down on it, right? But because this is a three-dimensional thing, I can actually look at it from the side. And so it's all I have to do is change one little thing. Oh, where's my, there it is. Change one little thing. I have to change the viewing angle from 0 to 90. Run that script again, and we'll look at it from the side. And I think these side views are kind of interesting. Oh, let's do it in GIMP here. And I actually think I like the fatter lines too. But yeah, so that's totally from the side. So you know, this axis is the parallax now. All right, so here again, you know, is our faint little star that had that high parallax. But now he's been rotated about an axis that is going this way, right? So it looks like a little line. But let's make those a little fatter. And then I'll show you what else I was doing. So instead of multiplying this by 1, let's multiply this like by, I don't know, 4 times fatter. Let's go 5 times fatter. So this will take a little bit longer to run. And
cue that brilliant Jeopardy music.
Yeah. You know, this way of doing art is, for me, very satisfying because I can't draw, you know, for anything, and I definitely can't draw this kind of stuff. And but I found a way through, you know, finding, you know, raw material and writing some software, and yeah, you make strange looking things like that. So you can actually, so what I was doing, I think, I don't remember.
So I didn't say that requires some slim fast by now.
So let's duplicate this layer, and then I'm gonna, on this new layer that we just made, I'm gonna do an edge detect. Oh, we got to change that to RGB. So let's do an edge detect on this guy. We get that, which is kind of interesting. Let's see. So if can we combine these? Let's see. Okay, we basically just get back what we got. Let's try addition. Let's try difference. Subtract. I don't know what the difference is between difference and subtract, but it's not. Oh, it's not visible. Combine, subtract. Anyway, you know, and I also sort of like this abstract stuff too. So yeah, it's just kind of interesting. Yeah, just thought I would show that off a little bit, and you know, one never knows where art is going to take you. So yeah, don't know yet. Don't know. We can actually change these angles. Let's discard all.
Definitely got some interesting colors and shape combinations.
Yeah, and it's all random, right? Well, the shapes aren't. The shapes are based on the brightness of the star. Let's not make them quite that fat. That's a little.
Looks better than some art that sells for millions.
Yeah. Well, you know, I figure if I do this enough, maybe sometime somebody will see it.
That was Enrico Roberto saying that.
Yeah. Well, you know, you never know. You never know. So I sort of set this at a little bit of an angle, right? So a 70-degree angle. So this is probably not going to look very interesting, but look at it anyway. You never know. Over to GNU plot and wait for it. There we go. Yeah.
Just out of curiosity, speaking of art that's that $1 million art, have you seen that little painting that was shredded half and half on the news and stuff?
No, I didn't.
So it's like it was sold, but then they turn on something and it shred like half the picture and stuff.
Oh my God!
So they got a shredder in the frame.
Oh wow!
Yeah, I don't remember that artist's name, but I guess he's done things like that before. Not that exact trick, but he's done some other.
Yeah, it's called the Banksy.
Yeah, he's famous for being famous or for being weird or whatever.
I see.
Sounds
Yeah.
Board, it looks better.
Gets a lot of money for his paintings, though, so good for him.
Yeah, you know, that are my thoughts exactly. Yeah. I mean, if you know, somebody wants that or likes that, it's like, well, you know, who am I to deny or judge or anything else? So yeah. Anyway, the other thing that I was doing was here. Let me put this back at 90, and we'll go 3. And I was playing with backgrounds a little bit too, because depending on what background you have, you can sort of enhance or de-enhance certain things. So here, I'll show you what I mean. So I've got that, right? And let's make just a new transparent layer that I'll put underneath that one. So then on that, what I can do, what's this called? A blend tool, right? So I can make this background, this transparent background, blend from this nice sky blue to black. All right, so I'll start about here, and whoop, I've got to make this RGB. So all this above here will be this blue, and then it'll fade to black all the way down here. See, so I can just do that. And then it makes certain things pop and certain things sort of recede instead. So we can do that. We can do like black and white, and maybe from corner to corner.
Okay, Erica Roberto's got a suggestion. Try getting some horizontal motion board on the top.
Some horizontal motion. Okay. I gotcha. I'm with you. I think I've got thought I had. Where is that? I know that I've got a blur or a. Oh yeah, here it is. Motion blur. So let's see. Blur parameters. Let's try to find one of these things. Oh, I'm looking at that. That's the wrong one. Duh. Yeah, let's do this one. Motion blur. So what you're saying is maybe well, let's just try that. This will take a couple of seconds to run. This is a 2000 by 2000 image. One of the cool things about GNU plot is that I can make this any size, right? I mean, if I want to make it 1,000,000 by 1,000,000, I could. Now, of course, my machine wouldn't be able to handle that. Hello. Okay, well, there's a little bit of motion. Yeah. Actually, that's a lot of motion. Yeah, I don't know. You know, there's so many things that can be done. 210. Let's make this length a little shorter. Yeah, maybe like that. Yeah. Yeah.
Sorry, Rico.
I don't know. Let's try a little bit of an angle. Again. Let's go like, I think 37 is a pretty nice number. Let's do that. Sort of fun to play with these things too from time to time. Yeah. Probably just need a longer motion blur to really make that interesting. I don't know. Let's go 117. That'll take a little bit of time. And then let's get on to Barnard Star. This has gone on far too long. It's so easy to get wrapped up in these kinds of things because you just start messing with stuff and it's like, oh, I'm going to try this, I'm going to try that. It's pretty fun. Yeah. Okay. Wonder what a say. I'm starting to do it right now. I should stop while I'm ahead. Doing an edge detect. Yeah, that's not too interesting. It's kind of interesting, but yeah, not really. All right, well, enough of that silliness. It's kind of fun though, just to grab that kind of data and see what can be done with it, right? How can it be presented? I'm always interested in trying to see how I can present astronomical data so it's more easily understood. So is this easy to understand? I don't know. Probably not. But it is showing aspects of the data, right? This is parallax, right? And the size of these things are brightnesses. So yeah, it's kind of interesting.
Well, it's definitely creative.
Well,
you should put that on T-shirt and sell it on Zazzle. What is Zazzle anyway?
I don't know. Zazzle is one of the many artsy sites, and I actually have a here. I'm gonna get back to this for right now. I actually have some sites with my stuff on it. Society 6, Redbubble, and Etsy. And yeah, I'm thinking I need to do something with those. So we'll see. We'll see. All right. Well, let's start taking a look at Barnard Star. So cheers.
You can upload original artist on all kinds of stuff, like T-shirts, mugs, and other stuff.
Mm-hmm. Yeah, yeah. I know Society 6 and Redbubble. You can get things on a mug. You can get it on like a cell phone case. You can get it on a comforter, on a shower curtain, on a clock.
Maybe you should have something like that, and I might order me a bedspread out of that.
Yeah, maybe I should. So, anyway, let's get on to Barnard Star. Barnard Star is.
While there's still time.
Well, there's still time, so I'm gonna exit out of GIMP for now. If you don't know about GIMP, that's another just absolutely fantastic tool that is comparable to Photoshop. Photoshop, yeah, I don't know enough about Photoshop to really be able to say if GIMP is as good as Photoshop. I don't know. Every time I've used GIMP, I've asked it, to do some things, and GIMP has always stepped right up. So does that make it better than on Photoshop? I don't know. So yeah, if anybody has a lot of experience with both of those, I would definitely like to hear how the two compare, because at least in my observation, I've used Photoshop a little bit. They seem almost identical to me. So yeah, maybe Photoshop has more functionality. Don't know. But yeah, let's start looking at Barnard Star. And the first thing that I always ask is where is it, right? That's sort of my first bit of interest is where is it, and can I see it? And it turns out that it is in the constellation of Ophiuchus, over by Orion. Is it? I I think it's east of Orion. Is that right? Let's start diving in. I think, you know, actually a really good place to start for newbie, or the advanced amateur, or even the pro, is actually back to the basics, and that is Burnham's Celestial Handbook, which I just so happen to have right here, almost at arm's length. Now, I think that Barnard Star should be listed under Ophiuchus. So let's give that a try.
You still have that book? It hasn't fallen apart yet?
Well, I think, is this the one? Pisces. It looks like it's in volume 2. Volume 2. Yeah, so here's volume 2. It doesn't have a cover, and the first page, the first blank page, actually probably a couple others too, are gone. It starts on the preface here. So yeah, and then there's one page, and then it goes right into Chameleon, constellation Chameleon. But we're interested in Ophiuchus, and wow, I turned right to it. Didn't quite turn to Barnard Star. Let's see here. Great Milky Way. Let's see, are they going to talk about Barnard Star? Ah, there it is. Oh, yeah. All right, so here they're starting. A whole section here on Barnard Star. Now, Burnham's Celestial Handbook, right, is a little dated, and this thing is out of focus. So I'm gonna. There we go. So Burnham's is a little outdated now, right? But the basic information is the same in terms of the history, when it was observed and how it was observed and all of that. The history of it is here, and that's what Burnham's does really well. Is if there's any kind of information about how this object was seen or named or observed or anything, Burnham's is going to have it, and so they do. So yeah, they're saying here that Barnard Star is an M5 red dwarf that has a magnitude of 9.53 and an absolute magnitude of 13.4. So remember, the absolute magnitude is the apparent magnitude if that object were 10 parsecs away. So our sun, right, has an absolute magnitude of, I think, like about 5.3, 5.2, something like that. So if our sun was 10 parsecs away, it would be magnitude 5.2 or 5.3, whatever it is. But since it's much closer, right? I don't know how much 1 astronomical unit is in parsecs, but it's very small. It's just much brighter, right? So the apparent magnitude is like negative 26.4 or something like that. Well, Barnard Star has an apparent magnitude, right? If you go out and look at it now, of 9.53, this says. But if it were 10 parsecs away, it would look magnitude 13.4. So pretty faint little star, right?
10 parsecs is 32 light years, something like that.
Yeah, 10 parsecs is 32, about 32.6 light years.
32. Okay.
Yeah, and the parsec, that distance is the amount of parallax that object has at that distance. If the parallax is it one? I think it's 1 arc second. I think so. So the amount of parallax is 1 arc second at a distance of 3.26 light years, which they call a parsec, and that's how they get. That's where that word comes from. Parsec and parallax are related that way. So, all right. Well, anyway, this guy, what makes Barnard Star interesting to us, and pretty much only to us, is its motion across the sky. This is when we observe it, it is the fastest moving object. That's not a planet or a moon or an asteroid or anything like that. You know, something outside of the solar system. This is the fastest moving object we know about. And part of that, of course, is because it's so close, right? Here, they say it's 6.0 light years, so 6 light years away. We'll sort of, we'll get on to Wikipedia and you know, sort of check these numbers too, because, you know, things change, measurements hopefully improve, so, you know, maybe there's a slight improvement to that distance and magnitude and all of that, right? But yeah, I guess so. It was discovered, and when they say it, I'm not quite sure what they mean by it. If it's the star itself or its motion, but it was discovered by Barnard in 1916 through some comparison plates that were taken in 1894 and 1916. So he had, you know, 2 photographs of sort of the same portion of the sky, right? And he lined up all the stars and noticed that at least one of the stars had seriously moved, right? Seriously moved. And so, you know, names it after himself. Why not? You know, discover those kinds of things. You've got dibs. Cheers. All right, well, cool. So, as I said, I think we're going to spend a little bit of time on Barnard Star. It's a, you know, it's. I don't necessarily think that there's anything particularly exciting or unusual about the star itself. I've seen a couple of things about some flares that were detected and all that, you know, so we can get into all that. But I think for the most part, right, this is just sort of a regular, boring old, run-of-the-mill red dwarf star. I'm trying to get my screen back up here. Type in the password correctly. Yay. So, but because of its unusual motion relative to us, everybody's really excited about it and have studied it to death, right? really, really take a nice hard look at this. And that's actually, what that paper that we were looking at yesterday was encouraging, right? It's like we need to keep looking at this thing. But it sort of seems as though it's been looked at quite a bit. And, sort of in hindsight, the data presented in that paper, there was a lot of it, right? There was a lot of data. So, yeah, this object has been studied pretty well, Here, we'll just go through a little bit here. This is a little chart that shows the motion of Barnard Star in the sky over the course of a number of years. So here, I'll hold that up. It's called the path of Barnard Star, 1880 to 2040 AD. So the chart is 30 arc minutes on a side, right? So that's the size of the full moon. And the little marks in the margin are 3 arc minutes apart. So here you go. So there it is, and you can see here's where it was in 2000. Here it is in 2020. All right, so that's about where it is now. Right? But, it is almost a 10th magnitude star. So you might be able to see a 10th magnitude star with binoculars, some pretty big. The 10 by 50s, you might be able to see a 10th magnitude star. If you're out, really, really dark, maybe. This is definitely what I would call a telescope object. You need, at least 4 inches, 4, 6, 8.
So it's either like a binocular viewing or telescope viewing.
I would say it's definitely a telescope. Definitely a telescope. Maybe binocular. Maybe. It's pretty faint. Almost 10th magnitude. That's that's pretty faint.
You think you would agree with this newcomer? It's just Jewish science, or do you think we should throw him out?
Well, Gregor's Dram, science is universal. And that's what this live stream is all about. We're talking about the universe in the context of astronomy. So yeah, this is for everybody, for sure. So welcome. Come on in, join the ever-growing crowd. We're beginning to look at an object in the sky. It's called Barnard Star, and this star is a red dwarf star, but at least from our point of view, it's moving really, really, really fast. And so, we'd like to understand that, and we'd also like to understand a little bit about the star itself. It turns out that just yesterday, or maybe just the other day, a couple of days ago or so, that star turns out that it has a planet going around it. So I think that's very, very cool.
You think it's more like a Jewish thing, like he was saying, or do you think we should throw him out?
I think that he is gone. Bam. The banhammer has been dropped.
Yeah, I just don't want to cause a family fire and stuff, even though I got a wrench and stuff, and I know Uncle Bill's got a wrench.
Oh yeah. No. I'm not quite sure where that person was going with all of that. So they are, everybody's welcome here. But for the most part, we want to talk astronomy. Um, Religion, probably not. Um, that's you know, everything's connected, right? Everything everything is woven in to everything else, right? I mean,
I
one.
think if you're anti-Semitic, I think you're not you're either for the Jews or not for the Jews.
Yeah, I totally agree with that. So yeah, I think well,
I think it's anti-Semitic you're against the Jews.
what what I like what I like is that the trolls are appearing, and that to me is an indication that this is catching on, right? And like I said, I'm out. I've got the harpoon, right? And I'm looking around, right? And when I see one, gotcha. So yeah, no problem. But so yeah, the fact that the trolls are coming around, I think that's an interesting indication that that makes my harpooning job all the more easier. And plus, it's really really fun to bam.
Please don't harpoon me.
Sorry, it's too late.
Must have healed up already then.
Too late. Well, it's a very very gentle harpoon. All right, you guys. Well, let's continue Barnard Star over the next day or so, or whatever it is. I don't care what it is. We'll go as long as we sort of want to here. That is the fun part about this live stream, is that we can dive into things, spend as much time as we want. Right. That is the cool thing about having a daily thing, is that you don't have to try to pack a whole bunch of stuff into one thing, and talk really fast and try to pound information into people's heads. Let's just let's investigate this together. And Barnard Star is a great thing, right? I mean, it's really really cool. If you look at it through a telescope, you're just going to see a star. That's all. It might look a little red, but that's it, right? So let's find out. Why is everybody so excited about Barnard Star? Well, because of its motion, and as I just said, new information strongly suggests that it has a planet going around it. And that's very, very cool. Not surprising to me at all, but it's very cool, right? To know that, there's a really, really, really good chance. That's pretty cool. So, but what else? What else? What else do we know and have learned about Barnard Star? Don't know. So I suggest that we spend, like I said, the next couple of days maybe looking into Barnard Star a little bit and seeing what this thing is all about. Because, I mean, like I said, it seems as though this object has been very well studied. I'm just looking at another. Series of photographs here. So the top image was taken at Lowell Observatory in 1937, and then the bottom image was taken in 1960. So there you go. So do you see it?
And this is Barnard's, right?
Yeah. Which one has moved? Can you see it? It's hard to do
Interesting.
this.
And so I think, speaking of trolls and stuff, I think we need to put some rules and guidelines and stuff.
Yeah, I can probably do that. So this guy there moved up to there. So that's him right there.
Okay, I see it now. It's a little blurry on the screen, but still see it.
Anyway, so yeah, that's how to find moving things. It's there are a little bit easier ways now because everything's digital. So it actually makes it a lot easier to find moving objects now. But during this time, and that's how like Clyde Tombaugh discovered Pluto, right? Was he had two pictures, and he put one on this side, one on the other, and then he had a machine that would actually blink between them, and he would just scan, right? Just scan the plates, looking for moving things, and wow, just incredibly tedious. But now we can write a program to do that, and it's actually super easy, and it takes nothing at all to do it. So, all right, well, more on Barnard Star tomorrow. I think I'm going to exit for today.
I think Enrico Roberto's got something for something cat on them to make it more entertaining.
Yeah. Except these cats are the masters around here, so it's like I'm powerless. I'm completely powerless. I cannot command them to do anything whatsoever. So, all right, you guys, I'm going to get out of here. So have a great evening, a great day. Yeah, gotcha. So make sure to subscribe if you haven't yet. Spread this around.
Cats versus trolls. I just want to sick my dog on them, or go UFC style on them. MMA, mixed martial arts.
Yeah. Well, to each his own. I think for me, at this point, right, it's an indication of exposure, and that is okay. For me, because what I'm trying to do is share this passion, and the more I can share, for sure, the better I feel. So yeah. I'm if this YouTube channel can grow, and I can share with more and more, then I am doing well. And that's why I succeeded on my first live stream, right? Because I got a few people to watch, and it's like I did it. So yeah, I've already achieved my goal for this live stream, and that is to have you.
That's what I'll do, Uncle Bill. Introduce them to your wrestling buddies. Yeah.
There you go. Yeah. All right, you guys. I'm gonna get out of here for sure this time. So take care, and I will see you again in a little less than 23 hours from now. So take care. Peace, cheers, and all that. All right. Bye.